Yes, we are live now. Please start.
Okay, so good evening, everyone. I hope you all are doing great. I'm Madhuganda, and today's industry expert session is on edge computing, which is the next generation landscape bringing the change. And we will discuss its need and use cases. To make us more familiarized with this field, we have with us Mr. Lalit Mohan, sir. Sir has a career mix with academic and industry across public, private, and foreign entities. He has an experience of 20 plus years of at various roles in banking and financial services technology. He has worked at Wells Fargo, IDRBT, and Infosys. He has executed projects for World Bank, Microsoft, and so many organizations. Anything I say is like little addition to his aura, and I think we are going to learn a lot today. And without taking any further time, I would like to request sir to please begin today's session. Over to you, sir. Thank you so much for joining in.
Thank you, Madhuganda. So I'm also a learner, right? I continue to be a student and would want to be a student. And I was a student till a couple of years back when I was trying to go back to the school and do PhD full time at IIIT-Hyderabad. So yeah, I certainly enjoy being in the college environment than any time in the corporate. What I thought today is bring about. I'm not going to talk about algorithms. I'm not going to talk about anything that is purely theory. But I felt I should touch upon where some of these research that's happening in the academic world. What does it mean for the industry? And I'll try to see if I can focus a little bit around the banking and financial services, primarily because if you look at if there are $100 to be spent in technology, $34, so which means about 34% of the IT spend in the world happens in the banking and financial services. So the banking and financial services are one of the largest IT consumers in the world. But if you go to any bank, your first reaction would be, yeah, they are probably using an outdated technology. Um, I don't think so always. And in fact, the country India has some of the latest, greatest technologies in the banking and financial services that can beat any other country in the world, including the innovations that happen in the US, European market, or in the China market. For that matter, what you see as RTGS, NEFT in the country, or UPI in the country, I think there are very few countries that can even think of competing with India around those just on the payment services. Now, what I thought for today's talk is around the next generation computing, around edge analytics. Um, I'm assuming that we have in the participant list all kinds of learners like me, right from students in the college, or probably there are professionals trying to go back to the school, and so on and so forth. So I'll take little history and then relate to what's happening in the edge world and why that is becoming very relevant in the current times. Um, I would continue to do my talk in case you have any questions. You can put in the chat window, or probably we can use the last few minutes for the question answers. Right. So I'll get going. What I try to put you, the first slide is around obviously the banking financial services, around a space in the banking and financial services called capital markets or a stock exchange. You would see the tickers, and the tickers that you're seeing in terms of the real-time pricing that's happening certainly can benefit if there is an edge computing, and I will get to that why. So just going back to the history, I don't know how many of you have seen a mainframe or heard a word called mainframe. In fact, when I was a student, there was another lab mate I asked my lab mate, who was suddenly an undergrad student here, did he hear the word mainframe or did he hear the word called Fortran? And I was suddenly not so surprised because he could not even spell the spelling of Fortran, which is formula translation. So one of the programming languages that NASA continues to use, and that's something people in my generation did as programming course. Like some of you would have been doing C, C++, or a Python in your first year. I did Fortran in my first year as a programming coach. Now, what I wanted to tell you is the importance of why Edge is becoming clearer and clearer. Sorry. So there were those days where people were only using mainframes. So there was some centralized machine. They were machines otherwise were very expensive. People were not able to buy individual machines because those machines that were available only large machines, and they were the sizes of big rooms. The mainframes that I saw were almost 20 by 20. So a big bedroom or a big hall kind of a size, and there were even bigger ones, right? So people used to use that environment, which was more of a centralized, but very capable in terms of compute. They do about millions of transactions or millions of instructions per second. They call it as MIPS. Today we use it as CPU, and we talk about in gigahertz. Mainframe still uses a term called millions of instructions per second. Right? They were more in terms of uh, I mean, it's a one large process, but yeah, it's not multi threads that run. There was only one single thread that was running and was responding very fast. That was the era when people were using one central machine. And today, there are still large organizations which continue to use those age-old or the current uh, probably refurbished or extended warranty mainframes even in today world, including in some large banks. In India, I know only one bank, not a normal bank, but a centralized regulator kind of a setup which uses mainframe for, but they use Z Linux, not the original operating system that typically you would find on IBM machines. So India that way certainly caught up with the latest current technologies because our effort in terms of technology started much later than most of the developed countries. Then came the era of IBM PC, or you would have heard about XT machines of what Bill Gates got, and that developed into a DOS operating system or disk operating system. So there were those diskettes. People used to put those diskettes in the machines, and then the machine used to get booted on. I used it as latest as 1970, 1997, 98 time frame, right? I graduated in 97, but I used it from 93, 94 onwards. So your operating system was pretty much a character user interface. And today, a lot of people still love the character user interface that comes on Linux. But I also see a lot of people slowly shifting to the user interface, a GUI based interface. So there was a shift from centralized to the PC, and the PCs were getting cheaper, and every application was just sitting in one single machine. So it was a more of a monolithic. And then people realized, yeah, we need to have some machines which are more powerful than the regular PCs, and there could be a client server architecture. So there is this one central machine. There are not dumb terminals like in the mainframe, but there are little intelligent, little capable machines on the client side that could keep interacting with the server to work, to execute the whatever the task. Then you all must be hearing about AWS, OpenStack, Azure, GCP, DigitalOcean, Heroku, etc., etc., etc. in terms of cloud. And that became very relevant because otherwise organizations were spending quite a bit in terms of managing data centers, buying servers, replacing those servers or refreshing those servers. And banks, which are those 34%, their business is banking, their business is not IT. But they were spending quite a bit in terms of just the bank here, managing the IT. Now, banks, not just the banks, but world over, people started looking into how we can use the cloud. That kind of, again, is central, but not so central like I have it in my own house or in my own data center. Now, during the same period, we started seeing mobile devices becoming very capable, right? A 1 GB RAM machine in late 1990s was also really an exciting machine to have. Now, if you have a mobile which is less than 4 GB, probably people will see you otherwise, right? So mobiles have become very powerful. They have become cheaper. Now, with that 4 GB RAM, with the capabilities of processing much better than what PCs used to be even in the mid 2000s, that certainly provides an opportunity for pushing some of the computing from cloud to the edge device, right? It could be the mobile, it could be your laptops, it could be your cars. And today, while Tesla is a story of its own, but most of the normal cars have more electronic parts than mechanical parts. So, at some point of time, if someone talks about automobile engineering in our thoughts, in our minds, it was generally a mechanical engineer or an industrial engineer, more so a mechanical engineer or an automobile engineer. Today, cars are certainly more of electronics engineers or more of computer science engineers rather than necessarily the mechanical engineers. I think for the shaft, for the wheels are the only places where the mechanical engineers play a role. Otherwise, pretty much an electronic device or an electrical device or a mechanical or a computer device, right? And that has large compute, right? They talked about Tesla having more powerful computers than some of the mini organizations having Tesla cars having more powerful computers than some of the mini organizations running their servers, right? This kind of shifted how the compute was happening from a centralized to a client server to a cloud to putting the data into the edge. And that's where the opportunity in terms of edge computing becomes necessary. And that edge computing is going to improve dramatically. It has already improved in most of the world. China has seen a big impetus. US is seeing it, and India will start seeing it even more. And I'll get to the point why so in India, right? Next, I just wanted to get you some clarity. One of the comments that you keep hearing, or if someone talks about a software architecture, if they have not used the word microservices, probably, yeah, they're not building the current applications, right? Microservices is the way that people are building those applications. What is a microservice? Microservice is a small unit, a small serviceable unit. And Martin Fowler, who is considered as the guru of software engineering, has an interesting definition for microservice, and that's how the microservice word got coined. When there are milliservices, there are nanoservices, there are microservices. Today's world, microservices and nanoservices are becoming more relevant. Um, yeah, I think I don't have the exciting definition like what microservice would have for a nanoservice, but let me explain what Martin Fowler mentioned by means of microservices. He says microservices essentially is a self-sufficient functionality that is developed by a team of members who just need one pizza to feed them. So one large pizza, if probably it can feed 6 to 8, max 10 people. That's the team that is built to deliver a microservice. Now, these microservices in today's world are typically, I'm trying to go to the show the upper part, are typically deployed on a cloud. So each microservice is independent. They could be interacting with one or many databases. They could be interacting among themselves, and they would get exposed through an API gateway, which is kind of providing an interface for the people to directly consume the API as is through a JSON or a GraphQL, or probably some people still use SOAP, probably SOAP. I don't think SOAP really matters here these days. It's the REST APIs or the GraphQL APIs. There are also sort of interfaces that you can build on top of it. So you could have a mobile device, and that mobile device has a mobile app, and that app, while it might have some logic built into the app, if it has to make any server connection, it would make the server connection to a microservice coming through an API gateway. Now, which means anytime that you want a data request, anytime that you want to get something new, you are essentially making a trip to the cloud, right? Now that's changing these days. What is changing these days is now these mobile devices or any of the current edge devices are also equally powerful. Now they have obviously the moment that we are talking about edge computing, there is a compute, there is a CPU, there is a RAM, there is a storage. And why you should make a trip to cloud always? Let's take a scenario. You all, I'm guessing, have an Aadhaar. It doesn't happen today, but you all have an Aadhaar. I'm talking about instance. Today, you want to do a Aadhaar verification of to log into, let's say, a mobile banking app or to your COVID app. What happens is the COVID app raises the request, it goes to the Aadhaar website, and Aadhaar comes back with a response saying that, yeah, this person is authenticated, or throws a challenge in terms of an OTP on the mobile device. Probably you would enter the OTP and then get authenticated to do whatever operations you want to do on a COVID. Now, let's take a scenario where the DigiLocker is some app that is available. DigiLocker is the one which stores the Aadhaar, and that is securely stored on your laptop or on your mobile device, and that's only available to through a authenticated service through exchange or some JWT tokens, JSON Web Tokens. Instead of making all the trip to the Aadhaar, so there is one central DigiLocker sitting in your your data wallet on your mobile device, and your COVID app, your mobile app for banking, or some other app for passport wants to know whether your Aadhaar number is correct. Instead of making a trip to the Aadhaar data center, they could make a trip to the another microservice that is securely sitting in your own mobile device, right? So a microservice to microservice interaction happening within the device, not making a trip to the cloud. This obviously reduces the latency. This obviously reduces the requirement of sending data, getting data, and the data means cost. And obviously, over the network means security challenges. If I'm able to secure the service app in my own comfort level in my own device, I'm reasonably assured about the security and privacy. And that's essentially what's changing with the increased compute storage memory of the edge devices. I'm just taking a mobile device. The smartwatches have become much more capable in terms of compute, storage, memory in the last few days, in the last few years, right? IoT devices are not anymore just the PLC devices that are just sending some signals. They also are getting that capability in terms of compute, storage, and have an IP address, right? So that is the capability of what edge computing is bringing into the picture. Now, I touched upon what is edge computing and what is changing and what is going to change even more dramatically is the way the use cases are changing. Right? If my VR or an augmented reality app, and today we are more fascinated about the term called metaverse. Probably some of us are not, especially in the last 1 month, ever since the crypto took a real hit in the market. Yeah, people have some negative notions, but just imagine the technology as is, not worried about the money part of it. That if it has to be really effective, your VR experience has to be great, your metaverse experience has to be great. It cannot every time make a trip to the cloud, right? The edge devices that are sitting in your VR gadgets, that are sitting in your mobile devices, are actually the ones which are taking care. In fact, there are a lot of use cases where, except the rendering part, that happens on the VR device. A lot of data push, a lot of action actually happens in the mobile device, which is considered to be more capable than the VR gadget, right? So it's already getting into the picture in terms of what mobile devices can do. Then there is the angle of 5G, 6G. 5G is going to happen in India if everything goes well from August onwards, at least in the metros. 5G talks about 1 Gbps, sub-millisecond latency. You could be on a bullet train at 300 miles per hour. You could still get the signals without any um, losing the connections. Right? 6G talks about not 1 Gbps, but 6G talks about 1 Tbps, 1 terabits per second. And in India, we might not see 5G at a 1 Gbps, but it's reasonably assured. And some of you, if you have visited IIT Madras Research Park is one of the pioneer in terms of the 5G innovation that's happening in India. 5G, 6G, they all benefit or all actually drawing their benefit in terms of bandwidth, lower latency is because they are not doing just packet switching, but they are using the base stations, they are using the towers, they are using their pico cells, they are using the cloud minimally and just looking at how do they distribute some of the packet switching, some of the traffic, and reduce the overall period to transfer the packets, right? And that there's a concept called mobile edge computing, MEC. It could be a mobile device that could actually go act as a tower in your 5G. So it could also be communicating or helping to communicate with other mobile device rather than always connecting to the signal to the tower. They're also looking at how do they put some intelligence at the tower so that if there is a connection that needs to happen between one mobile device to another mobile device, either they could directly talk or they could talk to the tower close by rather than going all the way to the data center of the telecom service provider. Um, Another example, right? Blockchain is suddenly is all about distributed computing. We are talking about more and more distributed computing coming, whether it's the Web3 or or in terms of DLTs, and they are all thriving on edge computing. What I wanted to say is the emerging technologies that are coming, whether it is bionics, whether it is quantum computing. Quantum computing, we are still talking about very capable machines. Um, but largely, I can see over a period of time, edge becomes embedded into some of these emerging technologies. That way, we just see it as like the way we make a phone call or the way that we breathe, right? We don't realize that we are breathing, but yeah, we get that action going. Edge is necessarily in that direction. Right? Some more use cases. India is talking about 100 smart cities. Um, we have seen recently IIT-Hyderabad talking about uh, a drone where a human can sit. I mean, IIT Hyderabad in India, but I'm sure they are equally good, and they're also looking at what's happening across the world from a research and from implementation perspective. And if a drone has to work, or a metaverse has to work, or Sophia, um, in the last IIT Madras convocation, I saw Professor Bhaskar Murthy sir talking about doing, I think, VR AR based convocation. I don't know if it is last year or the year before, but Sophia is a name that we all would have heard or will hear or have seen in some way. They are all benefiting the capabilities of the edge computing. Right now, this is some of the statistics. What I'm trying to bring to you all is while there is a lot of research that's happening in the emerging area like edge computing, there are already benefits that the industry is reaping, right? And this is an industrial use case, not just the industry use case, but industrial. So there is a concept called Industry 4.0 which is talking about how machines to machines interactions, how the entire automation happens in the organization with less human or human less interventions, which means uh, the machines will go manufacture the cars, and it's already happening today, right? They would do the monitoring, not only monitoring, but they would action based on the monitor results that come out. So it says, yeah, there is some leakage somewhere, probably raise an alarm, or not just raise the alarm, go correct it. So Industry 4.0 is suddenly a big revolution that's happening around, and the base underlying fact is the availability of capable edge devices, and not just the capability, but their intelligence in terms of handling the requests, making a sense of the sensors outputs that are coming out while processing it. Now, one stats talks about, I'm not going to read the stats, but one stats talks about, probably you're already having it. Every human would have at least 7 connected devices. So I have a smartwatch, I have a smartphone, but yeah, I just have 2 in my immediate distance, within my reachable distance, But they're talking about every human would have at least 7 connected devices in their reachable distance in the next 2-3 years, and that obviously means lot of data, right? There's a view that uh, people have, the amount of data that we all would have generated in the last 50-60 years is equal to the amount of data that we would have just generated in the last 1 year, right? So that growth of data is becoming more exponential, and that growth of data would increase with 5G. If someone is talking about 1 Gbps, obviously you would not need, you are no more interested with HD 4K movies, you would be looking for 8K HD devices. I remember when I had 3G, my data connection was 250 MB per month. And 250 MB per month, I hardly used to consume it. And today, most of us, I know, at least students would certainly do it more. We consume not less than 1 GB or 2 GB in a day, right? Where is 250 in a month, and where is 250 MB in a month and 1 GB in a day, right? And that's coming out because on a 4G connection you're seeing 8 Mbps, max of 8 Mbps. Theoretically, it can go up to 10-20 Mbps, but max 7 to 8 Mbps. Now, the moment 5G comes in, it can go to 1 Gbps in ideal situations, but 100 Mbps is going to be quite common, which would mean most of us would do a lot more things on the mobile devices than what we would do, and that would mean a lot more data being generated, and that would obviously mean a lot more analytics that can happen with the data, right? So exciting period. And then I thought I should talk about more specifically around my own passion, which is in the banking and financial services. I spent about getting close to 25 years in banking and financial services. So all my life in technology has been in this area, be it the retail banking, be it the commercial banking, or more recently in the investment management. So let me take some um, use cases that I'm mentioning here, right? Metaverse, next generation branch. You would have seen an article from JP Morgan, Onyx. They're talking about Onyx branch, where you go to a branch in a metaverse world and you don't trade in the dollar, but you trade in the Onyx coins. So they're talking about virtual currencies. They're talking about not physically going and still being able to operate, right? And the strength of that is how your VR, how your analytics, how your decentralization web or DeFi, decentralized finance is all coming together, and the underlying platform is obviously Edge, or the capabilities of using Edge devices to provide that seamless experience. Second, micropayments. I don't know how many of you would have heard about you could make money while browsing, right? So when you do a browse, you're actually essentially doing a labor work. Who's benefiting through your work? Obviously, some search engines or some people bought data from search engines. They're all making money. And let's say that you're in India and the guy who's benefiting is in US or in Europe, and you are doing this labor. You obviously in a real world, when you do a labor or when you work, you want to get paid. And in this case, we are talking about someone being in Europe, US, and you're in India, and you're spending 5 minutes of browsing, which means my edge device here needs to make an interpretation that I need to make some money out of it. Maybe in a virtual currency, maybe in a coin that we both accept, understand into our wallet. That is more of a Web3 kind of a setup. But at the end, uh, whether the information of me browsing something that is relevant to them and then getting paid for it is happening because the capabilities of the edge device, and that micro payment not necessarily has to go to a NPCI or a UPI or a RBI to get that payment release. It could be going to my wallet, my crypto wallet, sitting in that same device, and there could be some authentication that happens around, and I could get paid. So for a 1 cent for my 5 minutes browsing, I don't need to really bother big servers. I could just go to my wallet, and that my wallet sits on my or someone's wallet sits, and I get paid through that wallet for the browsing that I did, right? That P2P transactions or person to person transactions need not require a round trip or need not go to the central service for making decisions. And what I'm talking is not about some fancy things happening. They are actually happening in today's world. You search for TD Bank in Canada, you would see the topic that I'm talking about, P2P transactions. Data wallets. I'll come to the data wallets immediately. Give me a couple of minutes. Hyper personalization. Large banks, small banks thrive on how they would use the data. So the data on mobile device, the data of what you purchased, the data of where you moved, and then accordingly show you the specific screen when you log into your mobile app of the bank, show you that specific screen. So if I'm probably spending some time on the Facebook, or probably went around doing some sightseeing, and that sightseeing has some wonderful scenic places to take pictures. I think if my bank can show when I log in to the mobile app of the bank, it shows, yeah, probably there is an opportunity to buy a nice camera or a nice iPhone. That would be really so cool, right? And no one is sharing the data. The data is on your mobile device, the data is on your edge device, and the personalization is happening on your local machine, your local edge device, rather than sending the data to the cloud, right? Embedded finance. Embedded finance is you make a e-commerce purchase today. Some of them are already doing it. Some of them are some time to get into that direction. But embedded finance is you don't even realize that you have to open the HDFC screen or punch into the different interface of ICICI or SBI. So it is embedded into your e-commerce portal. It is embedded into um, your um, your mobile app, and you would do operate on your app as normal as you would, and the transaction just happens behind without requiring for you to really come into the banking interface to make it happen. And the reason that it can happen is because Edge, with its capability, can get you the security, the banks that can rely on that security, and because of the way that 5G or whichever generation of technology that's changing the bandwidth, it can also do that authentication, rather than waiting for a long time for something to clock around for you to make any decisions. So embedded finance is certainly a nice use case that's happening around. High frequency trading. I don't know how many of you are invest in mutual funds. If not mutual funds, at least in stock, or probably if not stock, mutual funds, I should say, because stock is suddenly more volatile, right? Obviously, the returns are also higher along with the risk that comes along with it. I'm guessing some of you believe mutual funds, तो सही है. So from the angle of the trading that you do on the stock markets, right? How markets make money is basically someone is buying, someone is selling, and the difference that between the buyer and the seller is someone's profit, right? Now, if you know that you want to buy Infosys stock or XYZ stock, and rather than calling the distributor or logging into some app and then making a transaction, and that means there is a latency. You filled in the number of stocks that you want to buy, shares that you want to buy, then you put in the amount. By the time the price would have changed, and probably you would buy some limit, and you are losing the benefit of, you would have seen at 95.65. By the time you are keying in, it would have become 98, or it would have reduced to 95.4. The best thing would have been the trading can happen then and there. And that's the high frequency trading. And that can essentially happen with a combination of how your edge devices can become capable, as well as how the bandwidth like 5G can really help. The next point that I wanted to talk about is the data wallets. Right? I touched a little bit about you browsing, making money. Let's say you are in a situation where you need to submit your proof of identity. Right? It could be your Aadhaar card, it could be your driver's license, it could be your voter card, or your proof of address, or the transactions that you are doing in the bank, or the browsing that you are doing on the e-commerce portal, or on a search engine. Now that's essentially all the data that you are generating, or the applications are generating on your behalf. Now, if there is a data wallet, and the data wallet can happen because there is a capable edge device, and that data wallet, if someone wants to get my transactional data, and I authorize saying that this transactional data can be used by Amazon for this period of time in return of something that I get it, that's going to be so nice, right? With a concept like data wallet, you not only authorize who can use your data, you can also probably limit in terms of what the purpose that they use it for. So they're not going to always, they're not going to pull the data. They're going to send what they need, and if everything matches, you would give them a response back, and that's pretty much. So your data is still in with you, in your control, and obviously, rightfully so, right? It is your data after all. It is not someone's data. And today, you don't know where the data is. You don't know what is big search engine companies, big techs are doing. You don't know what e-commerce portals are doing. You don't know probably what the banks are doing. At the end, it's your data. You should have under control. You should know what can be paid at what cost, because the data of Amitabh Bachchan versus the data of Lalit, there is a difference, right? I'm certainly nowhere as prominent or as famous as Amitabh Bachchan. Now, the pricing of Amitabh Bachchan should be different than the pricing of Lalit in terms of sharing data. And Amitabh Bachchan should decide how much he should sell it for, rather than some bank deciding what the data is worth for, right? And that data wallet can happen only if there is actually a capable edge device in the machine. Now, let me summarize with what the benefits of edge computing are. Privacy, certainly, because you keep the data with you. I mean, the edge devices are capable, and the edge devices start getting used more. The data is not anymore sitting in the cloud, It is not sitting anymore in some client server machine. It's not sitting anymore in some mainframe. But your device, in this case, probably assume your device is your mobile phone or your device is your smartwatch, and you have a control of what the devices should be. So your security and privacy, it your own capability. I mean, probably these devices provide their own uh, local assurances, but at the end, you control rather than someone else controlling your data, right? I'm more comfortable when I lock my house rather than someone else locking and guarding my house, right? Cost. What I've been talking about it is from an edge computing perspective, how it would benefit individuals, but it would also certainly benefit organizations. It would also benefit overall the ecosystem, because the moment you start sending data, data upload is okay, but data download from most of the cloud service providers is an expensive deal. Um, Now, what the statistics talks about it is because of the way that edge computing can become relevant and the capabilities that it can do in terms of managing data, the overall cost in terms of the just the data part would come down by 70%. That's a big number, right? 70% of the cost would reduce if edge devices are properly managed. Performance, obviously latency is going to be minimal because it's not going to make a server trip. If I have to pay to you rather than going to UPI and then coming back, like the way if I'm taking out cash and giving to you, it happens instantaneously. UPI also happens in less than 3 seconds, but giving instantaneously is going to be much faster on a mobile device. So performance is going to be obviously at a different level. Your time to market, right? So you understand your devices very well. You don't have to worry about buying servers. You don't have to worry about connectivity. Yeah, you use what is that you can push to the mobile device and get things rolled out faster than otherwise. User experience, undoubtedly, right? In combination with latency, time to market, the experience is going to be much more appealing than otherwise. Latency, performance, I would relate to almost same stuff. Carbon footprint. This is something more relevant these days with ESG, right? And environment sustainability governance. Most of the countries, India also talked about by 2030 they would reduce carbon footprint by so and so. Some big organizations went about claiming by 2050 they would be zero carbon footprint, which would mean that they would, if they're banks, they would not give loans, or if they're banks, they would also ensure whatever that power consumption that they were doing for their own computing devices almost gets to zero, right? And the data, if what the benchmarks talked about with, if I'm doing cloud computing versus I use the capabilities of the edge, the carbon footprint will reduce by 90%. Right? That's really cool thing. Finally, the interoperability, right? You could connect to the microservices, APIs, rather than going, yeah, when would, if I host an API on Amazon, or if I have some workload on AWS, not Amazon, AWS, can I push that workload to the GCP, or can I push that workload to the Azure? Not sure, unless they are all interoperable. Today, that is certainly a challenge. And with the capabilities of Edge, that interoperability becomes much easier, because in the end, those APIs, microservices are sitting in your own device rather than going and making some trips. Right? I talked about edge analytics and I'm getting into edge computing. What I would encourage all of you to do is look at some of the references that I've given. LF Edge, Mimic is one of the most exciting organizations. In fact, the founders of Mimic are the people who got involved in the mobile device invention, and they have Kathy Wood. Kathy Wood is the lady who invested in AWS, who invested in Tesla as one of the board members. So she says on the site of Mimic, she says mimic or edge computing is going to be what Tesla has changed the overall market, right? So visit these sites, and if you want to play around, I would encourage you to try TensorFlow Lite. So you all understand probably in the analytics class, you would have used TensorFlow or you have used PyTorch, you would have used sklearn. TensorFlow has a converter, so you could write the code as you would typically write using TensorFlow libraries and use the converter to do it to a lighter version that you can go deploy on an IoT device or a mobile device, so that the decisioning, which is the testing or the decisioning, need not go to the cloud for the recommendation or the decision to happen, but it can happen actually on your edge device, like the way you would have seen when you say, "Hey Google," um, or Alexa, or Hi Siri. If they're connected to the internet, they'll still go on a case-to-case basis. But even if they are not connected to the internet, they at least come back with a response. It doesn't mean that hey, the Siri device or the Google device actually have a recording there. They are actually understanding the request and responding irrespective of whether they are connected to the network or not network, for at least for some of the use cases. And the technology behind is obviously the analytics, right? So you're already experiencing it, and I would earnestly request you all to see edge computing as not something new, but actually go develop applications and practice in your any of the application development journeys. That's pretty much what I have. Thank you. Happy to take feedback, happy to address any questions.
Thank you so much, sir, for the insightful presentation. Uh, you said like it's already in its initial stage. How long do you think till it's time for its complete adaptation, and what kind of like job profiles do you see there in edge computing? Because many of the people would be interested in knowing that, right?
Right. So it is, if you go to the LFH, the Linux Foundation site that is promoting the edge computing, right? The journey has already begun. People, we are already starting to dabble with cloud, and cloud is becoming almost a normal today. In next 3 to 5 years, edge computing would become normal, right? We wouldn't really get worried about what the hell is the edge computing. The reason that it will become normal is obviously the way the 5G is expanding across the world, and that would help in terms of not today the mobile devices are capable, but they are not really connected to a high throughput bandwidth, right? With 5G, that bandwidth will not be a challenge. So some of the testing, recommendation, personalization with that bandwidth can become much easy on these already capable devices. So 3 to 5 years, my bet is going to be a new normal with edge computing. Right? On the job profiles, I think 3 to 5 years is too long period to think about job profiles. As long as you understand service-oriented architecture, more specifically microservices, or you know how to deploy your machine learning models, not really looking for large data sets, not looking for large computing devices to train, test. You start bringing the efficiency in terms of engineering. Uh, I mean, at the end, a phone is never going to be a supercomputer. A phone is never going to be a large mainframe, right? It is going to be limited to what it is. It will be certainly better than a computer device today, but it is not going to be that behemoth machines, right? So it is importantly efficient for the people who are in the programming world to write really uh, write good, follow good practices when they're doing the test data or managing the data, or actually writing their code for training or testing the models. So it's the engineering effort that is more critical.
Yeah, and people who are actually interested in edge computing can also get into the research side, because since it's new, there is a lot to find out and research about.
Absolutely.
Yeah,
Absolutely. Security and privacy is an interesting topic. Analytics is an interesting topic. How do you create service mesh, which means there is an API, there is another API, both sitting on the same device. You can create a service mesh so that they know that the routing need not go to the central server, but the routing can happen in the device itself. So if any of you have experimented with service mesh like Istio, that could be another interesting area.
yeah. And one of the coolest applications that you mentioned, like data wallets,
Correct?
is it kind of a like, as a data scientist, we are all studying data science. How should we look at the data wallet use case of this edge computing?
Right. I mean, what is data wallet? Data wallet is basically in your normal wallets, right? You have not money, you have cash. I mean, you have now we all talk about data as the new oil or data as the money, right? If you look at any of the businesses, well, let's not talk about whether they're doing good or bad, but Zomato, Swiggy, Paytm, Amazon, they all thrive on data, right? And today you don't have that control on the data, and you don't have control in terms of who they what they use it for, what they make out of it, who do they share with, and edge devices becoming capable, whether it is your smartwatch, your smart fridge, your your laptops, your or your mobile devices or your tabs, right? You could have a wallet or a app, if I have to be simpler, and that app controls in terms of how there could be data coming from various locations, my data, and I could be having a wallet, and that wallet allows or disallows the requests that are coming to consume this data, right? And I make money out of it. Um, it is certainly unique. It is certainly existing wallet today, but there is already a research that's happening around data wallets in the internet. If you look at it, you would find already people making money for browsing.
Yeah. Also, like people who are actually interested in edge computing, they can look over the references that you mentioned and like read more about it. It will be really helpful, I guess. And if you guys have any questions, you can put it in the chat box. And like, so you said, like, there will be a time that we will have 7 devices around us. I actually have 5 right now with in front of me with me. So yeah, 7 wouldn't be too far. Thank you so much, sir, for like a really insightful session. It was really an interesting topic, and looking forward to interact with edge computing soon. Thank you so much for today's session, sir. Any ending notes you have?
No, thank you so much for giving me the opportunity, and I wish all the students a very best of luck and happy learning.
Thank you,
Thank
sir.
you.
Thank you so much. Yeah.
Bye.
Um, yeah. Balaji, sir, we can stop the live stream now.